this, it's more of the same, but then we're asking you to do some operations with it, like the sine of 30 degrees. Well, I know the sine of 30 degrees is 1/4. We just talked, or 1/2. I was squaring it already in my head. So sine of 30 degrees is 1/2. It's the distance up on a short triangle. Well, the cosine is √3/2. So the square root of 3/2, keep in mind, if we're squaring that, some things square and other things don't. The 2 will square. So that's going to be 1/4. The radical 3 squared won't square. The square just cancel the radical. The 2 will still square those. So that's plus a 3/4. And that's equal to 4/4, which is equal to 1. And what we're trying to get you to see here as we start to do these things is that when you square a sine and cosine of the same angle, in this case here, it equaled 1. It's the tall triangle here. So the sine of a tall triangle is √3/2, but we're going to square that. Plus the cosine of a tall triangle, which is 1/2, we're going to square that. We end up with the same two numbers, so we're going to equal 1. Well, does that work with all triangles, or does that just work with triangles that are 30, 60, 90 degree triangles? Well, wait, look at this. This isn't even a triangle. Cosine of 4 pi is equal to 1. Well, I'm going to square that. Plus the sine of 4 pi, same location, that's a 0. I'm going to square that too. Guess what? It's also equal to 1. So that being said, if it's true, and we didn't test one that's a 45, 45, 90 triangle, but if you did that, you'd end up with the same thing. Sine squared plus cosine squared is equal to 1 no matter what angle you're talking about. Okay? So select any angle, verification complete. The coordinates, no matter what, when you take any x and y value of any location on the unit circle, you're going to get sine squared plus cosine squared equals 1. And while I'm at it, just something to think about. When you're doing the Pythagorean theorem, you got a squared plus b squared equals c squared. If you can picture this inside of a unit circle, all right, that was pretty good actually, and that's your center. Your sine of this angle is that vertical distance. It's your y value. So we hearken this to sine of theta, and then this guy here, this is your adjacent side. So that usually is going to be your cosine of theta, and then you're inside the unit circle. Your hypotenuse is always equal to 1. So if you look at that, when you square sine, it's not that you're squaring an angle. It's if you're squaring the sine of a value, it's called, you're saying sine squared theta plus cosine squared theta, which is your b. These things here kind of they're the same. A squared plus b squared equals c squared. It's the same thing as saying sine squared plus cosine squared equals 1. And so with a simple algebra, you move this guy over. Sine squared is equal to 1 minus cosine squared theta. Just like the cosine squared, if I move the sine over, it'd be 1 minus sine squared theta. These are going to get you kind of in gear for the identities that are soon to follow. We've only gotten 3 minutes on this video. Let me show you this identity just so that you can familiarize yourself with what's going on here. One thing you can do, let's take a look. If we're working with this side of the equation, and I did this one in class today, if we're working with this side of the equation, we say, okay, well, what can I do with this side? I've got sine of theta minus sine of theta times cosine squared theta. And I want to somehow turn that into sine cubed. Well, one thing you may want to consider whenever you have the opportunity to factor something out, and in this case here, the only thing in common is this sine theta. So if I say, sine theta, I've taken it out, coefficient out in front of here is a 1, so I'm left with a 1 minus cosine squared theta. Well, if I got 1 minus cosine squared theta times sine, and I go back up here and refer to this last thing that I looked at, 1 minus cosine squared theta can actually be rewritten as sine squared theta. So I write that there, sine squared theta. But I don't want to forget that out in front I have a sine of theta out in front. So if I'm multiplying this times that, sine first power theta times sine squared theta gives me a sine cubed theta. Lo and behold, that's what the other side is. A lot of times you're going to be working with this side with the idea of trying to turn that into that. And so, the way I see something like this, I'll say take that sine out and let's get rid of that cosine in whatever way we can. The more familiar you get with these identities, the easier it is going to be to see that, oh yeah, 1 minus cosine squared is just another way of writing sine.